everybody. So I'm Pasi Lautala from the Civil and Environmental Engineering Department, and I'm going to feel after I hear about all these fancy technologies, I really should be the first one, because we're kind of going backwards now in time. I always say I don't really have a expertise, but I like to doodle with the railroads and rail transportation. Many different things that obviously all they affect to the mobility. Today I'm going to be talking a little bit what we're doing with the grade crossing safety and how that relates to the mobility aspects, but those are some of the other areas that I've been doing some work with my colleagues. And if it comes to something really complicated like algorithms and so on, then I go to Tim Havens and a couple of other people because I just can't handle that. So, like I said, we're going to take a little bit of a step backwards. Until we get to those autonomous vehicles, we still depend on humans, and we depend on humans and their actions. So if we want to operate our mobility safely, we're going to have to rely on the human perception and their rational, sometimes, actions based on what we tell them to do. And that can be in the ways of warnings or guidance, and typically those are engineered things. Now, we typically develop the engineered guidance or warnings based on our empirical evidence, our experience, our analysis and judgment. Not that often there's really a whole lot of science when it comes to transportation behind that. But it's sometimes difficult to evaluate how effective our engineered solutions or warnings are, because if you think about drivers, they like to be in their own vehicles, they like to be private. So it's tough to go and monitor them while they're actually driving. So one of our questions is that how do we better align our engineering and human elements so that we can improve the safe mobility and hopefully avoid situations like these couple here in the pictures. There's a new tool available for everybody here as well that provide some light on what happens in the vehicles, and that's called Strategic Highway Research Program Naturalistic Driving Study Database. And what they did, they instrumented over 3,500 private vehicles. They have over 5 million trip records all over the US. They tracked these people for about 1 year, driving around in their vehicles, just everyday driving. It includes all kinds of information: rear video, throttle, brake speed, acceleration, head tracking, and you can actually mine that data to collect, analyze driving data. There's some restrictions in place, but you can work around those. And there's also a related route database that we already have here at Tech. We got that from Michigan Tech Transportation Institute, so if anybody is interested in that. So what are we doing with this data? We are looking at the driver behavior at the highway, rail, grade crossings. And it's really a combination of using this data and then taking it a little bit step further to look at the simulators. So our project is funded by Federal Railroad Administration, and what we are doing is we are looking at about 15,000 crossing traversals, people driving across grade crossings, and people's only safety device really at grade crossings, especially at passive crossings, is their own eyes, their own feet, and their own brain. So we are trying to look, do they actually behave how we tell them to behave based on our warning signs? And if they don't behave that way, well, what else should we do as an engineers to give them better warnings so that they would be safer? So that's the first step. We are working on developing some methods for data reduction, automated head tracking, and doing scoring methods. And then once we have those in place, we're going to be working on the trending analysis. And finally, we have the simulators, but there's always questioning, well, is simulator data same as real data? So we are hoping to develop similar scenarios with fill art on the simulators and compare the results between ours and theirs.